Hi there, I'm How. This is another video of me solving great numerical problem. So non-overlapping interval. So we are given an array of intervals, co-intervals, where the step array, right, will be start and end, and we need to return the minimum number of intervals. We need to remove so that there will be no overlap. Right. So in this case, right, we have to remove 1 and 3, right, to make sure that the rest of intervals are not overlapping. Right. So the end time can be equal to the start time, right? That is okay. That is acceptable. Overlapping means the start time going to be less than the end time, right? So this is totally acceptable, right? 1 to 2, and then 2 to 3, right? If it is 1 to 3, then it is not acceptable, right? Right. So how can we approach this? We can first sort the interval by the end time and use a greedy approach on this. Right. So what do I mean by greedy? Greedy means that you need to keep track of the minimum end time as we iterate through intervals array. Because the smaller the end time, the less overlap we're gonna have, right? So if we have the larger the interval, right, the more possibility that we're gonna have overlap, right? But so in other words, right, the smaller the end time, right, the less overlapping we will have. Yeah. So whenever we found an overlapping interval, then we always keep track of the minimum interval. Sorry, the minimum end time, right? Because if we keep track of the minimum end time, which is our read approach, right? So the smaller the end time, the less overlapping we will have in the future, right? Hopefully, right? So let's sort this array, right, by the end time. Right, so the end time is here, right? 2, 3, 3, 4. Right? We don't care about the start time actually. Right? So we keep track of the minimum end. Right? So the minimum end gonna start at negative infinity, right? Which means that there's no overlap, right? So what does overlapping means? So overlapping means when the start time, right? The start time is less than the uh the min end, right? Right. So for example, if the min end is 2, right? So if the min end is 2, the min end is 2, right? Is 2, right? And we have like something like this, like 1 and 4, right? So which means it's overlapping because the current start time is less than the previous end, right? The min end. Right? So if the minimum end is starting at negative infinity, then we will never have overlap for the first comparison, right? Right. By making the minimum end at negative infinity, then we're not gonna have overlap for the first try. Just overlap, right? Count plus we need to increment the count. Mhm. Right, if the star, right, is greater than or equal to the min end, right? There's no overlap, right? And then update, we can update the min end, right? Okay, so let's try this out, right? So this is our first interval, right? we're gonna look at the current n. So because we are shorting it, the interval array by the n time from small to large, right? So we know that the large n time will always be toward the right, right? So when we find overlap, we can just get rid of it. Okay, so the end time is 2, right? And the start time is 1, right? So 1 is bigger, right? It's larger than the min end. So there's no overlapping, right? So we need to update oh, and yeah, we also have a count starting out at 0, right? To count how many times that we need to remove an element in interval, right? Yeah, because there's no overlap, right? For the first comparison, there's no overlap because the start time is larger than the minimum end, right? So we just update the minimum end to 2, right? Right, we need to keep track of the minimum end because so another way you can think about that is in order to include this interval, right? Then the minimum end that we need to have is 2 for is 2. Okay, so next we have 2 and 3. So 2 is smaller than or equal to the minimum end, right? So the the start time is not less than the minimum end, so there's no overlapping, right? So we need to just have to update the minimum end, right? So in order to include these two interval, right? The minimum end we need to have is 3, right? So the minimum end here is not like the minimum end time in the interval. So the minimum n here means the minimum n time that we need to have to include uh, these two intervals, right, up to the I index. Right? So if the I index is here, right, then in order to include these two intervals, right, with no overlapping, then we need the minimum n time of 3. Okay, so now we have overlap, right, because the start time here is less than the end time. Right. So in that case, we just keep the minimum n, right? We don't want to change it because we want to remove this interval, right? Right. Because we know that it is an overlap interval, right? And we are iterating from left to right. So we know that the current end time will always be larger than or equal to the minimum end, right? Because we shorted the end time from small to large, right? So if we found an overlap, right, we're just gonna keep the minimum end the same because we know that this minimum end we're gonna be either larger or equal to the current minimum end that we have, right? So whatever comes later will always be larger end time, right? Because we shorted. So we just have to get rid of that and then increment the count to 1, right? Okay, so now is here. We have 3 and 4, right? So the start time is not less than the minimum end, so that is fine. We're safe here. So we just have to update the minimum end to 4. And yeah, that's a bit of it. Right, we just have to return the count at the end. So the rents are going to be n log n, right? Because we need to sort it, and the space complexity going to be O of n or O of log n, depending on the implementation of the sorting algorithm. And yeah, the extra space complexity is just going to be constant, right? We just use a couple of variables here, right? So the idea here is that wherever we found, so you can also sort this by the start time. It doesn't really matter. But whenever we found an overlap, right, the greedy approach is that we need to take the smaller impact. We need to keep track of the smaller impact, right, and remove the interval with a larger impact because the smaller the impact, the less overlapping we will have, right? If the interval is smaller, they will not have less overlapping, right? As opposed to a large interval, a larger n time means more overlapping, more chances for overlapping, right? And because we are sorting by the n times, then we don't have to do any comparison, right? To see, okay, which interval has a smaller n time, right? We don't, because we know that the one that we are looking at currently will always have a larger minimum n, right? Which is the one we will get rid of because they are sorted from small to large, right, by the n time. Okay, so that is the whole algorithm that code this stuff. All right, so we need to sort the interval, right, by the n time, of course. The index one will be the index for the n time, right? So we need to count. We're gonna count the n, right, and the minimum n, starting out at negative infinity. Right? If we start out at negative infinity, then there will be no start time that's gonna be less than this minimum n, right? Which means we're not gonna have overlap for the first comparison. Okay, and then we need to iterate through the intervals array. We have the start and the end variable here, right? Gonna equal to intervals at I, right? So if the star is greater than or equal to the min n, we have to set the min n equal to the current n, right? Otherwise, we have to increment the count, right? So here, if the star is less than the minimum n, which means we have overlap, right? So we need to increment the count and get rid of the current interval, right? So we get rid of the current interval by not updating the minimum n, okay? And if it is if the start time is larger than or equal to the minimum n, which means we don't have an overlap, right? So which means we want to include that interval, right? And in order to include that interval, we need to update the minimum n to equal to the n, right? Because in order to include that interval, the minimum n here is the minimum n time we need to have in order to include x number of interval up to the current index. And it worked. Thank you for watching.